Hi to everybody and welcome you all to today's lecture. Today's lecture is on food canning. So in this lectures, this module, I'll be taking in two parts. Part 1, how to do canning. In part 2, I'll be talking about the different types of spoilage in the canned foods. So once again, I welcome you all to today's lecture. So what is canning? Canning means the processing of food in a hermetically sealed container by using heat so as to kill the spoilage and pathogenic microorganisms and to preserve the nutrition and quality of the foods. So what we are doing here is that we put the food materials in a container. The container may be a glass container or a tin can, or it may be the retort pouch. And it is hermetically sealed. What do you mean by hermetically sealed? Hermetically sealed means it is tightly sealed, so the air or the microorganisms cannot get inside, or the material inside cannot go out. So that is what we call by hermetically sealed. And it is subject to a high temperature, say around 110 to 120 degree or 21 degrees centigrade, 121 degrees centigrade. So as to destroy the spoilage and pathogenic microorganisms, including the spores. So that is what we do in canning. So you can see here the tin cans, you can see the glass containers used for canning. The sausage is processed in these glass containers. So how the heat is transferred? It is by the liquid foods, it is by convection, or if it's semi-solid foods, it is by conduction and convection, and in the solid food, it is by conduction. So who is this man? It's in the picture. He was awarded by the government around 12 francs by the French government in 1809. He discovered a process called as canning. Okay, so he is a French chef born in 1749, and he got around 12,000 francs. With that franc, he established his own canning industry. There's a commercial canning he started, the house of Herbert at Massy. So he is known as the father of canning. He is Nicholas Herbert, and he invented the canning in 1809. So he is known as the Nicholas Herbert is known as father of canning. So why to can the meat or any food material? So any perishable food materials we cannot keep for long durations. So if you want to extend the shelf life of that product, or if you want to keep it for a long duration, then we can go for canning. So meat is perishable and be preserved by canning, and it is easy and convenient to store. So most of the canned products we can store at ambient temperature. No need to maintain the cold chain, and it is of convenient pack size are available. So you have to, for example, say for a small one person, one serve, or multiple serves. So the convenient pack size are available, and it is very easy to use. Just you put it in the hot water and remove the lid and serve it. So it is easy to use and safe for consumption. Energy saving, because there is no need to maintain the cold chain for its preservation. So it is an energy saving. Minimal product spoilage, because the spoilage will be less in this type of product, and stabilize the market price. Because for example, if we take tomatoes, in particular season we will get plenty of tomatoes, and in particular season it will be very costly, say 40 or 50 rupees in India. But sometimes we can see the farmers are just throwing the tomatoes on the road because they are not getting sufficient price. So if you can convert the tomatoes in jam or the soup or the sauce or anything like that, which is canned products, it will help to stabilize the market price. So when we have plenty or surplus, what we can do is we can can it and preserve it. So the market values for that particular product can be a stable market price can be maintained. That is the advantages of canning. Types of containers used. So there are different types of containers we used. So mostly in the commercial canning, we go with the tin cans. That is, it is steel, made up of steel coated with a tin, so it is called as a tin cans. Usually cylindrical shape, so it consists of steel sheet which is electrolytically coated with a tin on one side or both side, inside and outside it will be coated with the tin, on the both side it will be coated with the tin. So the steel sheets of thickness of 0.22 to 0.28 mm thickness steel are used. Then it is coated with a thin layer of tin, or the chromium will be coated. The thickness of the thin layer of tin is 0.38 to 3.08 micrometer. So small thin layer will be coated on this steel bodies. So why we coat with the steel tin is that to prevent the rusting. Okay. The interior of the can is also lined with another compound that is called as sulfur SR coating. It's also called as sulfur resistance coating. So you can see different types of can, pear shaped can. So you can see in the jars, it is glass jars can also be used for canning. So in the beginning, the canning was done by Nicholas Ebert in the glass jars. So you can see this oblong cans. This is oblong cans. This is called OTS can, open top cans, open top sanitary cans. So it is called as OTS cans. So this is you can see it is coated with a tin, and they give an extra coating inside that is called as SR coating, sulfur resistance coating. This is especially given for the meat and fish products and the egg products. We give this SR coatings. So you can see the metal cans, the tin cans. So it is made up of steel, then it is coated with a thin layer of tin to prevent the rusting, and it is again inside it will be coated with acid resistance if you are using the cans for preliminary used for fruits, or it go with the sulfur resistance coating or SR coating for the meat products. So there are 2 pieces steel cans and 3-piece steel cans. So what does it mean by 3-piece steel cans? 3-piece steel can means that is a body, this is the body, then is the upper lid and the lower lid, okay, or the base we can say. Okay, so if it is 3-piece, then it is called a 3-piece steel cans. So we have the body here, this is the body, then lid, top lid and the base. So then it is called a 3 and in this types of cans, the large cans will have some ridges, because when you do canning, the high pressure will be developed inside. To withstand that pressure, we give this ridges or the splittings so that it can withstand the pressure. So composed of body and 2 bottom and the lid, made up of steel, then it is coated with tin. Then the modern cans are induction soldered. So here there is a joint. Okay, this is a sheet put like this in the cylindrical shape and it is joined here. So in the modern systems we go with the induction soldering. So induction soldering means it is just binding or combining the 2 materials, so there is no holes here. So the air will not go inside, or the microorganism cannot go inside. So it is induction soldering will be done here, so that the microbes cannot enter or the air will not get entered. So 2-piece can means the base and the body is made up of a single piece. Okay, the base and the body is made up of single piece, and that will have a lid. So normally you must have observed the aluminum cans. It is a 2-piece cans normally. It will have the base and the body is made up of single sheet. Okay, single sheet it will be made, and the lid is another. So it is called the 2-piece cans. So here have a lid similar to the 3-piece cans. Bottom and body consist of 1 piece. Okay, so in the mold that will be putting this sheet, and it will be made into the form of cup. So it will be molded in the form of a cup, like you must have seen the Coke or the Pepsi cans. Okay, it is a 2-piece cans we can say. Okay, cup shaped parts may be shallow drawn, it may be a shallow drawn here, or with a short sideways, or a deep drawn. So here you can see the deep drawn, long body is there. Okay, so it is a deep drawn cans, and you can see the bottom also. Okay, it can see the bottom also. So it may be a deep drawn or the shallow drawns. Normally these are made up of aluminum, or the steel can also be used, but commonly aluminum. The 2-piece cans we go with the aluminum cans. So what is the using of advantages of aluminum cans is that it is easy to use, usually deep drawn 2-piece cans. Advantages is low in weight, resistance to corrosion, good thermal conductivity, so processing time can be reduced, easy recyclability. But the disadvantage is that it is costly compared to that of steel cans. That is only the industry is not using this aluminum cans for meat and fish or the other products. Normally they go with the steel cans. So you can see the glass jars. This is not commonly used nowadays except for the traditional sausages and other things. They may be using this type of glass jars for canning. The reason is that because of the fragility, it can break easily. So it also consists of a glass body and a metal lid. It consists of a glass body and the metal lid. Seaming panels of metal lid as a lining of synthetic material. So it will have a synthetic materials lining inside and it will be seamed here. Okay, double seaming will be done. So as already I discussed, it is available in convenient size, oblong cans, shapes also, pear shape you can get this, oblong shape you can get this, conical shape you can get it, round cans we can get this, open top sanitary cans. So it is available in convenient sizes and shapes also. Coming to the microbiology of the canned products, the main culprits, because I told it is hermetically sealed, so there will be no oxygen or the atmosphere will not be there. So it is anaerobic condition. So in the anaerobic condition, two bacteria basically grows. One is the two, and we are more concerned with the two spore formers. One is the Clostridium, another is a Bacillus. Okay, so Clostridium is a thermophilic anaerobic bacteria. So it grows at high temperature and it grows in anaerobic conditions. Bacillus are facultative anaerobes. So it's let's discuss Clostridium botulinum. Why we are more concerned with Clostridium botulinum is that it produces the exotoxins. So what is exotoxins? When it is live only, it will release the toxins. There are two types of toxins, exotoxins and endotoxins. Endotoxins means once the bacteria die or the lysis of the bacteria take place, the toxins will be released. Clostridium botulinum, it grows exponentially in the media and it can produce the toxins, exotoxins, that is the neurotoxins. These neurotoxins are highly, the potency if you see of this neurotoxin, 1 gram of this toxins, pure toxin can kill around 8 lakhs people. So high potency is the toxicity of this Clostridium botulinum. So this we are more concerned with this type of bacteria because this bacteria Clostridium botulinum is present everywhere in the soil, it's present. So it's a gram-positive spore forming rods. Grow best in the anaerobic condition and environment around pH of 5. So it's normally grow above the pH of 4.5 and above, and it is a very optimum above pH of 5. Okay, so it is grow at pH of above 4.5 and the best environmental conditions above around pH 5. It's more favorable for this bacteria to grow. So it produces the botulism, and the botulinum tox blocks. How it works is that once the toxins is ingested by the consumer, what happens is this toxins will go and block the nerve endings, the ganglia in the nerve endings, and it affect the acetylcholine neurotransmitters. So it can lead to paralysis or muscular cramps can take place, nausea, vomiting, headache, and double vision is one of the typical sign we can see in the Clostridium botulinum toxicity. Okay, and other neurological symptoms. So that is why we are more concerned about Clostridium botulinum. So when you are doing the canning, it should be highly hygiene should be very important, and we have to subject the product to high temperature also, so that the spores can be destroyed, because this it is very difficult to destroy the Clostridium botulinum spores. So we have to subject to a high temperature. So coming to the types of food is that there are basically 4 types of foods we can say based on the pH or the acidity. So one is the low acid foods, medium acid foods, and high acid foods. So low acid foods means foods which is having less acidity, that is the pH will be more than 5 or higher, then it is called as a low acid food. So the most of the animal products, say meat, marine fishes, milk and egg, all comes under the low acid foods. So medium acid foods means 4.5 to 5. Example, meat and vegetable mix. So when you mix the meat with the vegetables, for example, say kurma, meat kurma or meat gravy types with vegetables, if you are making means it will comes under this pH. So 4.5 to 5. So it is a medium acid foods. Acid foods means 3.7 to 4.5. So you know the tomatoes, pears, fruits, and most of the vegetables come under acid foods. And high acid foods means the jams and the pickles, the citrus fruits, all comes under high acid foods. So as already discussed before, the Clostridium botulinum will grow above the pH of 4.5 or above the 5. Okay, So we are more meat and meat products or the animal products comes under this low acids and medium acids category. So we have to subject the product or the food to high temperature so as to destroy the spores also. So this is low acid foods. So meat and meat products, milk and milk products, egg and egg products, fish and fish products all come under the low acid, the category of low acids and the medium acid foods. So naturally, if you want to destroy the Clostridium botulinum spores, we have to subject to high temperature. That is why you must have seen the pickles are not treated at a high temperature, because it is having a high acidity. Yes or no? So, but in the case of low acid foods and medium acid foods, we have to subject to high temperature to destroy the Clostridium botulinum spores. So coming to the meat canning processes, so there are basically 8 steps we can say. Okay, first is can filling. Then after the can filling, we do the seaming operations. The temperature, so seaming or after the can filling, it goes for exhaustions. After the exhaustion, it goes for the seaming. Then it goes for the sterilization or the autoclaving. Then cooling, then drying and wiping, and labeling and storage. So again repeat, can filling, after that exhaustion, it is wrongly put. After exhaustion, we go for seaming operations, then autoclaving, retorting or sterilization. Then we have to cool the cans, then drying and wiping, and labeling and storage. So these are around 8 steps, or I have put here as 7 steps, labeling and storage. So it comes around 8 steps we can say. So this I'll be explaining each and every steps from starting from can filling up to storage. So let's take an example of meat canning processes. Let's take an example and discuss about that. For example, let's discuss about how we can make chicken curry. We can make different products, like we can make chicken curry, mutton curry, or we can make biryanis, or whatever the products you want to do canning, we can can it out. Okay, so for chicken curry, we require 2 things. One side we have to prepare the cans, and the other side we have to prepare the curry. Okay, so we will be using the OTS cans, and it will come in the crushed form or the flanks. So that flank should be formed into cylindrical shapes. So forming and one end seaming will be done. So we will be closing with the base. Okay, the base will be seamed and the cans are sterilized. How we can sterilize is put the cans in the hot water or the steam water. Okay, and it is kept for 45 minutes to 1 hour, and then the cans will be sterilized, because during the transportations of this can flanks, it may be contaminated with dust and other things, so it should be sterilized. Okay, on the other side, we'll prepare the meat curry. So meat curry, how we do it, we have to debone the meat. So it's always advisable when we go for the canning, go with the aged product or the tougher meat, because it is subject to high temperature, the texture can be maintained. Okay, so that is why we have to go with the tougher meat like. Okay, so you can take chicken, debone it, then you make into chunks, cubes, or mince, whatever shapes you want, you make it, then cook it out. So when you cook it out, we get 2 things. One is the cooked meat, and another is the stock solution or the cooked juice, because you know that meat will contain around 73% water. So when you cook it out, the water will be coming out, and we get what you call as a stock solution. This stock solution will be containing lot of flavor component fats, amino acids, okay, and vitamins and minerals it will be containing. So don't throw off this stock solution. This stock solution can be used for preparation of the curry or the gravy. Okay, then so we have meat, separate the meat from this stock solution, and the stock solution can be used for preparation of the curry or the brine. Then the filling should be done. So first you fill with the liquid, that is the gravy. You fill with the gravy, then you put the cooked meat inside this. Okay, and it is always advisable to do like that, because if you put the cooked meat first and then the gravy, if you put, there's a chance for air pockets to be formed between the solid materials or the meat pieces. To remove that one, first fill with the liquid, then you fill with the solid materials. Then after that, it goes for exhausting. So exhausting we do around 80 to 85 degrees centigrade or 75 to 85 degrees centigrade for 25 to 20 minutes, depending upon what type of material we use. Then it goes for seaming. Seaming means the lid will be closed, the top lid will be closed, and see that the temperature should not fall below 74 degrees centigrade at the center of the cans. I'll be explaining each and every step. Then it goes for sterilization or autoclaving or retorting. then cooling will be done, then drying and wiping. So then we clean the cans, then to remove the moisture that is present on the surface of the can, so the rusting can be prevented. Then it goes for labeling and storage. So let's see one by one, step one by one. So first is a can filling. So you can see these cans are filled. Okay. So deboned meat is used. Then we do what we call as a partial cooking. Partial cooking will be done, or pre-cooking it is called, or sometimes in the case of vegetables or fruits we call it as a blanching. In the case of meat we call it as a parboiling. So why we do this? To remove the enzymes and to prevent the eye expansion during the processing of canning or sterilization. Okay. So it also helps to remove the microorganisms. Pre-cooking or the blanching or parboiling will also help to reduce the microorganisms. It helps to destroy the enzymes that is present. Okay. Then after that it will be filled. So to what extent we have to fill in the cans? So we have to give the edge space. This is called as a edge space. In most of the cans it will be marked. Normally we recommend around 0.6 to 0.9. It depends upon the size of the cans. So don't fill up to the neck. That is very important. Why we should not fill up to the neck is that because during the autoclaving or during the sterilization it is subject to the high temperature. So this product can expand and it can break the seam, or the lid can be broken. Is it clear? The seaming where the lid is seamed with this one, it can break. So the seaming can break. For that one we have to give the edge space. So even if it expands, this space will be utilized. So, so normally 30% of the can volume can be filled with a liquid, so that help in the convection of the heat easily and the process can be faster. So we have to give the edge space. That's what I told, 0.6 to 0.9 centimeter. Again, it depends upon the size of the cans and what type of food material that we are using. So you don't fill up to the neck region. So let's see an automatic can filling. The can filling can be done manually or automatically. So this is a luncheon meat. Where we can see how the canning is, how it is filled like. So after the filling, it goes for the next process that is called exhaustions. Why we do exhausting? The basic is that to remove the oxygen or the atmosphere from the cans. Okay, to remove the air bubbles from the cans. So here the critical point we have to attain is around 75 to 80 degrees. So what do you mean by critical point? That is the coldest point. So if you take example this can, the coldest point is a geometric center, we can say approximately it comes here. Okay, if you do a drawing cross section like this, it will come like this spot. This is the coldest spot because the heat will be coming from the top, bottom, side and everywhere. So this will be attaining the heat. This point will be the coldest point. So that point we can just keep a thermometer here and we can just examine the temperature during the exhaustion process, which we are going to see. Okay. So here once you do around 75 to 80 degrees centigrade, when it attains, most of the air will be removed. Okay, so the air will be removed here. So what is the advantage of exhausting? It reduces the microbial loads. Basically it removes the oxygen, so oxidation will not be take place. If oxygen is present, if the tin coating is not proper, what happens? There's a chance for corrosion to take place. So to remove that only, we do the exhaustion process. Exhaustion is remove the atmosphere inside the cans or inside the food materials. So here the can will be kept in this is the exhaustion chamber, we can say. Inside that there will be steam will be injected, high pressure steam will be injected and the temperature will be maintained around 75 to 80 degrees and 85 degree we can go like. So we will be doing the exhaustion process for around 5 to 20 minutes depending on what type of food material that we use. So it will be just moving through this conveyor. You can see here it will be just moving through this conveyor into this chamber and it will be heated. So this will be just moving inside this chamber and it will be heated. So why we do exhaustion? To minimize the discoloration or due to oxidations. It also helps to maintain the flavor because sometimes the flavor loss will be taking place because of the oxidations. It also helps to prevent the loss of certain vitamins. prevent excessive pressure also, because when you do, if you are not doing if the airs are not removed properly during the sterilization process, after this the sterilization process where we will be subject to a high temperature, so the hair can expand and the seams can break. So this joint can break, or the seam at the lid can break. So to prevent that also we have to do. Exhausting at high temperature should be avoided to prevent excessive vacuum. So we have to do the exhaustion process around 75 to 85 degrees centigrade. That is the temperature we recommend. Okay. So the heat exhaustion, so you can see the chambers, through this chamber it will be going and it will be get exhausted. So it takes from here to here, it takes around 20 minutes. So we can adjust the speed of the conveyor, and according to that it will be moving. So how we can do the exhaust? One is by heat exhaust, that is you just fill it, keep it in the hot water, and you can just boil it out. Okay, so when you boil it out around 70-85, the hair will be removed. Next, by the mechanical exhaustion, that is by vacuumizing, we can do is steam injection. So here mostly we follow the steam injection. That is what we followed in, I showed here also. The steam injections will be it's a common method of doing the exhaustion process. So you can see here steam injections. So it is just coming out of this exhauster. So it takes around 5 to 20 minutes. Like after seaming, immediately it goes for sealing, or a lid sealing will be done. So we will be just seam it. This is hand seaming, or this is automatically it will be seamed. Okay. So after exhausting, cans are immediately sealed airtight by means of the sealer. So this is the sealer that we use. Okay, double seamer we can call this as, and it will be sealed. The temperature should not fall below 74 degrees centigrade. So see that the coater, so a person will be standing here, randomly he will be checking the temperature of this cans at the coldest point. So you will be just inserting a thermometer at the coldest approximately here, and you will be seeing the temperature. Okay, so why we say 74, above 74 to 85 only, the most of the airs will be removed, or it moves out of the container. So and it will be immediately, it will be closed. So once it closes, what happens is the moisture that is present will condense and it creates a vacuum. Okay, so the healthy cans will be concave. After closing the lid, it will be almost straight, or it will be mostly concave. If it is bulged, means it is not a healthy cans. Okay, which we are going to discuss in the next part. So after the seaming, lid seaming, it is put in the baskets. This is a perforated baskets. So this baskets, inside this baskets will be putting, and you can see there is a two layers. Like this is the retorter or the canner, and this is the basket. This is a perforated baskets like this. This is for vertical type, we will be using this type of basket. For horizontal type, we will be using this types of baskets. So inside this trolley or the baskets, we will be putting the cans, and this is hoisted and put into this horizontal types, vertical type of vertical type of retorter. Here it is a horizontal type. So this trolley will be moved inside the we use steam or a hot water for sterilization. So we will be subjecting the product or the can to a temperature of 110 to 121 degrees centigrade. We will be subjecting the product to a temperature of around 110 to 121 in order to kill all the spoilage and pathogenic microorganisms. Not only that, we have to destroy the spores also. So we will be subjecting to high temperature and high pressure we will be subjecting, and we will be destroying the microorganisms along with the spores if it is present. So heating process can be done by indirect heating by saturated steam. That is, we will be, this is, you can see here inside, this is in a thing of retorter where you can find it is saturated with the steam. So we will be using the steam and we will be sterilizing that one, or you can use the hot air and a closed convection method or direct flame methods. So we can follow any of the three methods. Normally in the industry system, we will be following this indirect heating by saturated steams. We will be injecting the saturated steam at a high pressure. We will be using this one. So normally the pressure that is used is 12 to 15 pound per square inch pressure we will be using in the retorter, and we will be retorting the product, or will be sterilizing the product. So for sterilization for each and every product, it will be vary according to the products. So you can see here, The sterilization time depends on the size of the can that we use. If it's a bigger can, it takes more time for heat to penetrate. You can see this is a cold point, or the thermal critical point we can say as. This is the coldest point. So this takes more time to attain the desired temperature. So because this is a geometric center. So this is the coldest point. So normally we keep a thermocouple here to monitor the temperature inside the product or inside the can. Okay. Then it also depends upon the pH of the food. If the pH is low, say highly acidic foods or acid foods, the processing temperature can be less. If it is less acid foods like meat, egg or fish products, there's a chance for Clostridium spores to be present. So we have to subject to high temperature to destroy the spores. Then it also depends upon the processing temperature. So if the processing temperature is high, then the processing time will be less. If the processing temperature is less, the processing time will be more. So actually for each and every product, we will be doing pilot studies, the lab studies will be done, and then we will be deciding the time temperature. Rate of heat penetration at the center of the can, and it also depends upon the what type of cans that we use, whether it's a pouch or a can, aluminum can or a tin can, what type of can. So it depends upon how fast the heat can penetrate inside these cans. It also decide the time and temperature. Type of organism that may be present, again I told you, if it is a high acid foods, there is no chance for this Clostridium to be present. So we no need to require high temperature processing. But if it is a low acid foods or a medium acid foods, naturally there is a chance for Clostridium spores to present. So we have to subject to high temperature to destroy the spores. So this we will be discussing in the next class in detail. So this is the vertical type of retorter. So we will be putting that baskets which is containing the lot of cans inside this retorter, and the steam will be ejected here. Okay, so by the boilers, steam will be generated and the steam will be injected into this retorter. This is the vertical type of retorters, and the steam will be just going and the pressure will be increasing. So normally the temperature will also increase. So this is how the retorter works like, and we can monitor everything, the temperature inside the can by using a thermocouple. So we'll be using a thermocouple to monitor the temperature inside the can, and the temperature of the around the baskets or around the cans can also be monitored. So there will be display units will be there which will be telling the temperature, pressure and everything, everything inside the retorter. We can do that one. So this is a horizontal still retorters. So here, as I already told you, after putting in this baskets or perforated baskets, we'll be just pushing these baskets inside this retorter or the canner, and the lid will be closed and the steam will be injected. Once the steam started getting inside, the pressure will start developing and the temperature will start developing. So for each and every product, as I already told, we will be keeping a particular temperature for a particular time. Once you attain that particular time temperature for sterilization, we keep at that particular time and it will get sterilized there. After sterilization, we go for the next step, that is cooling of the cans. So after sterilization, the cans should be cooled. So when you cooled, it should be cooled to around 36 to 39 degrees centigrade. So we have to see, we have to monitor the temperature. So we can cool it by injecting the cold water. So you can see here, from the top, we will be injecting the cold water and it will be cooled. So once you cool it out, what happens is the steam that is going in the surroundings will start condensing, and the pressure will start dropping down. So why cooling should be done? One is to prevent the overcooking. Suppose, say, sterilization you do for 20 minutes. Even if you are not cooling it, it will lead to overcooking and it will affect the texture of the product, the flavor of the products. It also leads to the burning of the products. So we have to cool it out. Next is to prevent the germination of the spores and thermophilic spoilage. By mistakes, if your processing is not proper, if you are under processed, then there is a chance for spoilage, or the spores may germinate, or the spores may not be destroyed. For that, we have to cool, because thermophilic spores will start germinating above the temperature of 40 degrees centigrade. So to be on safe side only, we have to cool it to below 39 degrees centigrade. And you also see that while cooling, the temperature is not lower below 36 degrees centigrade, because this temperature will also help to evaporate the moisture, that is condensed moisture, on the surface of the cans. So what a problem that we'll face during cooling? The problem that we face during cooling is that because when we inject the water, what happens is the steam outside the cans will condense faster. So the pressure will start decreasing, but the pressure inside the each cans will be higher. So if the pressure is high, there is a chance for the seam to break. So seam can break, or the seams cracks can occurs in the seaming region. So to prevent that one, what we have to do is we have to inject to counteract that pressure of the can. What we have to do is we have to inject the water at high pressure. Along with injecting of the water, we can also inject the pressurized air inside. So that will prevent the breaking of the cans. So we should be very careful. We have to examine the pressure, and according to that, we have to inject the water, high pressure water we have to inject it, so that the seaming break of the cans can be avoided. After the cooling, the baskets will be lifted, or the trolleys from the horizontal retorter, or the baskets from the vertical retorter can be taken out, and it can be washed. Okay, it can be washed with it can be washed using first by pre-rinsing with the water. Then detergent sprays can be applied to remove the grease and other materials. So sometimes during the processing, some greases or the fat materials or the food materials may be sticking to this one, so that can be cleaned out, and then it can be wiped with the clean clothes, and it can go for labeling. And after labeling, keep the food materials or the cans the temperature of around 20 to 22 degrees centigrade or lower than that. So that will help to improve the shelf life of the product. So it's always advisable to keep at a lower temperature. Lower the temperature you keep, more will be the shelf life of the can. So what are the equipments that is required if you want to start a retorter, if you want to start a canning industries? One is the kettle, double jacketed kettles you need it to prepare the food materials. For example, if you want to make curry or other things, for such things we need, for parboiling processes and other things, we need a jacketed kettles, and we need a retorter. Along with the retorter, we need a boiler also to generate the steam. These are certain important equipments that is required. And we also require the thermocouples, copper-based thermocouples. You can use it. This thermocouple can be fixed to this one to monitor the temperature of the cans. Then can seamers can also be it's also required for the starting of the company. Okay, so these are the few equipments, important equipments I have told you, which you have to think about before going for starting the plants or meat industries. Then we have to examine for the Take care. If you have any doubt, you can send to this mail, or you can call me in this mobile number. In the next class, we will be talking about the spoilage of canned foods. So thank you very much.